Oh, hi there. Look at that guy over there. Look how busy he is helping you out with your math. Isn't he busy helping you with your math? Oh, he must really want you to do very, very well. Well, that's true. I do want you to learn all this material. That's why we're looking at the chapter 4, linear relations, right now. So these are the things that we want to be able to do. Recognize linear relationships from various representations. Okay. And we'll take a look at that first. We want to know slope and intercepts, slope-intercept form of a line, graphing lines, and solving linear systems by graphing. One topic that shows up in this package, which I have mentioned, but we haven't really practiced, is parallel and perpendicular lines. So we'll discuss that again here, but do not expect many questions about that on the exam. One or two to reward you for watching this video and for paying attention in class very well. Okay, so it is a topic that can show up, but maybe not a lot. All right. So first, determine whether each of the followings is linear or nonlinear, and then circle our answer. Okay, so here's a table of values. X is going up by, and here's how you analyze these tables of values. X is increasing by 2, X is increasing by 2, and X is increasing by 2. Okay, that was easy. Y increased by 2. Wait, Y increased by 4. Wait, Y increased by 8. If I check the slope here, all right, and then we want to visualize these things so that we can understand why they're not linear, because this is definitely not linear. If I check the slope there, it would be change in y divided by change in x, and that would be 1. Here, the slope change in y divided by change in x would be 4 divided by 2 is 2. And then here, 8 divided by 2 is 4. The slope is changing, so it's not linear. Linear means the slope is constant. So let's visualize it. Here is my xy axis. Here's 210, 4, 12, 6, 16, and 8, 24. Okay, it's doing something like this. Okay, it's curvy. It's not linear. That's why this is non-linear. This is a line, so it's linear. Linear. That looks like the line y equals 1/2 x. Okay, this one here, I can look at it and say, I am squaring x. Squaring things is not the same as not squaring them. Okay, all lines can be written y is equal to some number m multiplied by x plus some number b. This is almost that, but it's got an x squared. That's not linear, non-linear. This you'll study next year. It's quadratic. Grade 10 material. Okay. Oh, there's more of them. Let's take a look. Oh, it's not a line, so it's non-linear. Oh, that should have been up with the other ones. Oh, well. That's non-linear. It's not a straight line, okay? A straight line is linear. This is not. It's curvy. Okay. This one here, oh, that is y equals mx plus b. M is minus 2. B is 5. It is linear because it can be written as y equals mx plus b. Let's take a look at this table here. X increases by 5. Increases by 5, increases by 5. Y decreases by 4, decreases by 4, decreases by 4. If I calculate the slope here, it's always going to be the same rate of change. The change in y and the change in x is always the same ratio, okay? Minus 4 over 5. So this is linear. Okay. State the x and y intercepts of the following using proper notation. Okay, so the x-intercept is where it touches the x-axis. That's at the point -2, 0. Maybe I need to zoom in for you here. Zoom in more. Move this up. There. See that? It's at the point -2 in the x, 0 in the y, so that's it. The y-intercept is up there at 4. So we would say it's 0 in the x, 4 in the y. This is a horizontal line, and it has a y-intercept also at 1, 2, 3, 4 in the y, 0 in the x. These are always written alphabetically, so we always have the x first and the y next. And there is no x-intercept because this don't touch the x-axis nowhere. So you might say NA or none. Okay. All right, and over here, let's calculate the x and the y-intercepts. So this is something I'll be having you do for sure. So to notice with my x-intercepts, the y is always 0. With the y-intercepts, the x is always 0. So that's what you use to find these here. So let's just substitute in. Let's let x be 0. So we're going to have 3 multiplied by 0 minus 2y. And we're going to solve that for y. Okay, 3 times 0 is 0. Minus 2y is equal to 6. So let's divide both sides by minus 2. Y is equal to minus 3. So our y-intercept is 0 minus 3. Let's do the same thing, but for y. And I'm just going to work upwards here. Okay. Ooh, let's get the cursor out of there because the cursor's in your way. All right, so 3x minus 2 times 0. Okay, so that just basically goes to 0 and it's gone, right? Like this whole thing is gone. It's just 0. Anything times 0 is 0. So it's gone. And so 3x equals 6. Well, let's divide both sides by 3. X equals 2. Okay, so then we have here 2, 0. And there you go. Those are your x and y intercepts. Solve by substituting in x is 0 or y is 0. I don't memorize this stuff. I just visualize it. Okay. Let's work on this one here. So we're going to find the slope and the y-intercept and then write this equation in y equals mx plus b. So here's what I would do. I would say, okay, I got this linear relation, 2x plus 8y is equal to 32. This is hard to visualize. It's easier to visualize when it's in y equals mx plus b. So let's put it in y equals mx plus b form. Then we'll be able to read the slope, read the y-intercept, and punk our answer in there for that answer. Okay. So I noticed that my y and my x are on opposite sides of the equal sign. So let's do that first. So we're going to subtract 2x from both sides. So we will have 8y is equal to negative 2x plus 32. Okay. And then we usually have y alone, not being multiplied by 8. Y is alone. So let's divide both sides of the equation by 8. Okay, so 8 divided by 8 is 1. So you have y alone, isolated on that side. Hooray. Negative 2 divided by 8 is the same thing as negative 1 over 4, but it's multiplied by x. That's my m, is minus 1 over 4. And then 32 divided by 8 is 4. So that's plus 4. Okay? And there it is, ladies and germs. Sorry to all the gentlemen. There it is. That's our line in y equals mx plus b form. So we can put that over here. Y is equal to negative 1 over 4x plus 4. We could also write that as y is equal to negative x over 4 plus 4. They are equivalent. Oh, you can't see? There you go. I can write them both ways. Both are correct for all the beans, correct for all the beans. Okay? And then let's say, what's the slope? Well, m equals negative 1 over 4. So the slope is negative 1 over 4. It's the m value. The y-intercept expressed as an ordered pair, these are ordered pairs up here, right? Ordered pairs. So the y-intercept has a y value of 0 and the x value equal to b. b is 4. So this is 0, 4. That's what we're looking for. Great. And that's how you would take apart a question like that. Let's go to our checklist and see what we've done successfully so far. I'm getting so close to the bottom of my checklist. I'm so excited. I can recognize linear relations. I can work with slopes and intercepts. I can work the slope-intercept form of a line. Like I can create that from a different form. Okay, now let's look at graphing lines. Okay. Oh, there's more of these types of questions here. So, all right. I need to here figure out the slope, the y-intercept, and all that for this one. All right, so let me zoom out just a little bit. First, the slope, I'm going to use this point here, which is 6, 0, but it's negative 6, 0. And this point here, 0, negative 3, okay? And let's do, all right, change in y and change in x with those 2 points. So m is the slope, and it's always equal to change in y or difference between the two y values, divided by the difference between the two x values. And so in this case, it's going to be y2, we can use this one, minus 3. All right, minus 3 minus 0, all divided by 0 minus minus 6. Okay, that's equal to negative 3 over 6. That's equal to negative 1 over 2, reduced form. All right, my b value is minus 3. So that's 0 minus 3 is the y-intercept. It's right there. Just read it off the graph. And so I can take these two numbers and put them together into y is equal to negative 1/2 x minus 3. And that's in y equals mx plus b form. Correct for all the marbles. All right. A linear relation passing through the points minus 3, 2 and minus 6, 7. Woo! We have to find the equation of a line from 2 points. I love it. Okay, let's go. So first we want to find the slope. Okay, so here, the slope is going to be, again, m is equal to y2 minus y1 divided by x2 minus x1. And that will give us 2 minus 7 on top. 2 minus 7 all over minus 3 minus minus 6. And that's equal to negative 5 over 3. Yeah, good. So there's our slope. Now we have to go ahead and find the b value. All right. So we're going to set this up as y is equal to minus 5 over 3x plus b. Okay. And then we will have, let's use this one here, minus 3, 2. All right, we're going to substitute that in. This is x. This is y. So this is 2 is equal to minus 5 over 3 multiplied by minus 3 plus some value b to make it true. So here, this 3 will cancel that 3 because we're multiplying and dividing by 3, so that's just 1. And so we have minus 5 times minus 1. This is 5. So this is 2 is equal to 5 plus b. Well, if I subtract 5 from both sides, I'll have 2 minus 5 is minus 3. So b is equal to minus 3. And therefore, the y-intercept is 0 minus 3. It's the same one as above. So here my equation is y is equal to the m value, minus 5 over 3x minus the b value, which is minus 3. And that's done. Full marks for all the beans. Now we get to parallel and perpendicular lines. Parallel lines have the same slope. Same slope. So let's look at this example. This is a linear relation that goes through 1, 3, and it's parallel to this line that has a slope of minus 3. Okay, so the m value is the same. It's minus 3. Okay, and it goes through 1, 3, so let's calculate the b value. Y is equal to minus 3x plus b. Now we need to solve for b using this point, 1, 3. So 3 is equal to minus 3 times 1. I substitute 1 in for x and 3 in for y, like that, plus some value b. Okay? Minus 3 times 1 is minus 3. So I have 3 is equal to minus 3 plus some number b. Well, b is 6, because minus 3 plus 6 is positive 3. So b equals 6, and my y-intercept is 0, 6. So now I can write this in y equals mx plus b form. Y equals negative 3, because that's m, x plus 6. Good for all the marbles. Perpendicular lines. Perpendicular lines have, their slopes are related, as you can see. It's the negative reciprocal of the slopes. It means you have to flip the fraction over and make it negative, and then you have the slope of the perpendicular line. So first we need to find the slope of this relationship. Okay, so let's do that. So I'm going to rearrange that into y equals mx plus b form on a separate sheet of paper. Here. So here we go. 6x plus 5y equals 30. We're going to move that 6x over there, and we'll have 5y equals negative 6x plus 30. And then we divide both sides by 5. The whole side doesn't matter in this question, but it does. Whole side. Okay, negative 6 over 5 is the slope we were looking for, x plus 6. Now, the only thing I need from here is the slope, because I know that this line that we're looking for is perpendicular to that line, but it doesn't care about how high up or down that line is. And that's what's going to change that's what the b value is going to change there. So I really only need that minus 6 over 5 thing. So the m is going to be equal to this fraction flipped. So this line is perpendicular to a line with a slope 5 over 6, x. Okay, so that line, 5 over 6. I take this number, I flip it, and then I flip the sign as well. That's called the negative reciprocal. Has come up in class a couple times, and we haven't done much practice with it. So that's how you find the slope of perpendicular lines. You flip the slope and make it negative. Okay, so m is equal to 5 over 6. And the y-intercept, we were given it. It was 0, negative 2. So this line is y is equal to 5 over 6x minus 2. Now, this is a good time to look at these things in Desmos. Yeah, can we use Desmos? You can in your prep. Oh, look at that guy. He's so busy still teaching you math. All right, yes, you can in your preparation. You can't on the test, though. And that's okay. It's still good to use this for preparation. So here I had this one line, which was 6x plus 5y equaled 30. Okay, there's that line there with its y-intercepts at 6 and 5, which shouldn't surprise us because 30 divided by 6 is 5, and 30 divided by 5 is 6. So that's how they built that. Okay, and then we had this other line that we created, which was y is equal to 5 over 6 x. Notice that they're perpendicular. Okay, that very much looks like a right angle. Minus 2 there. That's the equation. Something with a y-intercept at minus 2 that is perpendicular with that line, and then finding that point of intersection would be a fun thing to do, wouldn't it? You could do that in grade 10 with some algebra. I wouldn't ask you to do that in grade 9. All right, let's keep going. Oh, don't mind if I do. All right. There we go. Zooming in. My colleagues have all abandoned me. I'm burning my bridges with my colleagues so that I can bring you these math lessons. Angering people for the sake of your math progress. All right. What's the slope of this line? Well, slope is rise over run, right? How much does this line rise? It doesn't, okay? So m is equal to 0 over whatever, like whatever I choose, 0 over 1, 0 over 2, 0 over 3, it's still all just like 0 over whatever. So 0 is the answer. Put an arrow at it. M is equal to 0. The slope is 0. The y-intercept, it's up there at 0, 4. So this line written out would be y is equal to 0 multiplied by x plus 4. But anything times 0, doesn't matter what x is, it's 0. So this is y is equal to 4. That's the equation in y equals mx b form. You would simplify. Yay! All right, last page of linear algebra. Okay, graph each of the following linear relations on the same grid and label them. Cool. Okay, y is equal to 1/5 x minus 1. Here's my process. M equals 1 over 5. That's rise over run. And don't forget, you could also do negative 1 over negative 5. That's the same thing as 1 over 5. Negative 1 over negative 5. Same. B, on the other hand, is minus 1. And so that gives us the point 0, minus 1 as the y-intercept. So let's go and plot that. Boop. 0, minus 1. Okay? And then we're going to rise 1 and run 5. Rise 1, run 5. Boop. Rise 1, run 5. Boop. Okay? run negative 5, rise negative 1, negative 5, negative 1, negative 5, negative 1. Okay? And then you go ahead and get a ruler, put a straight line through that, or do it by hand for some good practice. Okay? Even if I used a ruler, I'd still use algebra to find the values of those different values in between. Okay, so now we label it, right? This is y is equal to 1/5 x minus 1. All right, now let's take a look at this one here. Ooh, this is not in y equals mx plus b form. Ooh, we better figure out a strategy to graph it. All right, here's two strategies. One strategy is turn it into y equals mx plus b form and do what I did up there. I'll show you that. The other strategy is just find the y-intercept and the x-intercept, plot those two, put your straight line in. I'm going to do that first. Okay, so I'm going to find the y-intercept by letting x be 0. So that's 0 now, and I just need to solve for y is equal to 20. So y is equal to 5. All right, so when x is 0, y is 5. Put that on there, that's 0.05. Okay, now let's do this one. Y is 0, so it's gone. 5x equals 20. So 5 times some number is 20. X is 4. So that's over here. Boop. All right, and there's my line. So I can just put I can go down here. And then I can also just repeat this. Like I can go down 5 over 4, down 5 over 4 to there. And then back 4, up 5 there. All right, so there's my whole line. All right, now I kind of rushed through that because I knew I was going to show you another method, and then I would wow you with, oh man, they're all the same. Subtract 5x from both sides. Okay, so then you end up with 4y equals negative 5x plus 20, and then divide both sides by 4. So y is equal to negative 5 over 4x plus 5. Okay, so then we would say, all right, we are going to go plot this point 0, 5, because the b value is 5. So when x is 0, y is 5. Boop, put that on there. 0, 5. Okay, and then we're going to go rise negative 5, run 4. Rise negative 5, run 4. Rise negative 5, run 4. But we could also rise positive 5, run negative 4, and get back there. Okay, and that will give us all these points too. Okay, so it's the same. Different ways give you different ways of checking your answer too. Okay, I would probably do this. I probably wouldn't do intercept, but it's a nice trick to check. The good points to check are your intercepts. All right, last one is x equals 3. Let's see if we can graph this one. X. Oh, we should label this line. My goodness, this is 5x plus 4y equals 20. There. Now let's in black do the line x equals 5. Sorry, x equals 3. Here is x equals 3, but x equals 3 is all these points have an x value of 3. Okay, and all those points have an x value of 3. And together these three lines make a little triangle, and then I might ask you to find the area of that triangle in grade 10. All right, so there's the line x equals 3. It's a vertical line, and horizontal lines are of the form y equals 5 or something like that. All right, so that's all the graphing. Now, we want to find the point of intersection of these two lines. So first one, I'm going to do this one here. Y is equal to 1 over 6x plus 5. So I first put on the y-intercept of 5, and I go over 6 up 1, over 6 up 1, I'm off the graph, back 6 down 1, back 6 down 1, I'm off the graph. So that's some line that looks something like this. All right? Right. Okay, and then 4x plus 3y is equal to negative 12. Okay, so let's rearrange this into y. You want to do intercepts or do you want to do rearrange? Let's do rearrange. So we're going to subtract 4x from both sides. We're going to have 3y is equal to negative 4x minus 12. We're going to divide both sides by 3 to get this line. Y is equal to negative 4/3 x minus 4. Okay, so we're down here at minus 4. So if we run 3, we rise negative 4. But if we run negative 3, we rise 4. If we run negative 3, we rise 4. There it is there. Okay, put a line through it. Bink. All right. Just use your slope to find where they intersect. So this intersects at the point negative 6, 4. So the point of intersection is negative 6, 4. Mr. Jennings, how do I check my answers here? Well, you plug in these values, okay? Negative 6, 4. So I put that in there. 4 times negative 6 is negative 24, plus 3 times 4 is 12. Negative 24 plus 12 is indeed negative 12. Okay, so it works for that one. Let's check it over here. Y is 4. Okay, if x is negative 6, then you have negative 6 times the sixth, which is negative 1, plus 5 is indeed 4. So it works. Any questions, hit me up by email. Bye.